Okay, so today we're going to look at triangles, and triangles are pretty simple, and they're things that you guys have done before. You've done this in year 6, okay, but there's a few things that we need to go through, and perhaps the most important one that you know is the angle sum of a triangle. And all triangles, no matter what type of triangles they are, add up to 180 degrees. So a triangle is a 3-sided polygon, okay, and they come in all different shapes and sizes. Some are really long like that, okay. Some have wider bases, okay, like that. But every single one of them have an angle sum, so angles on the inside, that add up to 180 degrees. Now, when we look at classification of triangles, it can make it a little bit easier for us in finding out what size angles they are. We're going to start with side length because there's 2 different classification types. First, you can classify triangles by looking at the size of the sides. Next, you can classify triangles by looking at the size of the angles. So I'm just going to draw up probably a triangle that everyone's familiar with called an equilateral triangle. And an equilateral triangle, the reason why it's called an equilateral triangle is because all of the sides are the same length, okay? So that's why it's called an equilateral triangle. One of the other things about an equilateral triangle, because all of the sides are the same length, our internal angles are also the same size. So we don't actually need to know any of the internal angles to find out the sizes of the angles of an equilateral triangle. If there's 3 angles and the angle sum of a triangle is 180 degrees, it means that all of these angles are going to equal 60 degrees. Now, the second one is the isosceles triangle. And the isosceles triangle has 2 lengths that are the same size, okay? So there's 2 lengths and a base. What that means is with an isosceles triangle, and once again, we classify it because there are 2 side lengths that are the same. But because it's an isosceles triangle, these 2 base angles, we're just going to name them angle A, are the same length. So if we know one angle in an isosceles triangle, we can find the rest. So let's just imagine that this angle here is 30 degrees. That means that we could find out what angle A equals by taking 180, taking away 30 degrees, and then dividing that answer by 2. Okay, obviously we're going to end up with 75 degrees for our base angles there on that one. The next one that we're looking at is the scalene triangle. And the scalene triangle is probably similar to, let's just draw a triangle, and it has 3 different side lengths. Because of that, all of our internal angles are different, okay? So scalene triangle has all different sizes for the sides, okay? And isosceles has 2 the same, and the equilateral has 3 the same. Now, we also can classify triangles depending on angle size. So the first one is an acute angled triangle. And actually all of these triangles up here are acute angled triangles. And the reason why they're acute angled triangles, except for this one isn't an acute angled triangle. We'll talk about that one in a minute. But the reason why they're acute angled triangles is because all of these internal angles are less than 90 degrees, okay? So a triangle is an acute triangle if all of the internal angles are less than 90 degrees. An obtuse angled triangle is like this one here, and we can see this angle up the top is greater, more than 90 degrees. So if you have one angle in a triangle that is more than 90 degrees, it means that it is an obtuse angled triangle. And the last one is a right angled triangle. In a right angled triangle, you would have seen before, it's just simply a triangle that has one angle that is a right angle, okay? So in this instance, it's this one here. It's usually, okay, displayed by having the right angle marker in it, okay? But sometimes you might be doing some problem solving and it won't display a right angle marker. However, a right angled triangle has one angle that is 90 degrees. You cannot have a triangle that has 2 angles that are 90 degrees. The reason for that is we only have 180 degrees to play with in a triangle. So we've got acute, obtuse, right for angle sizes when we're looking at interior angles, okay? And then we have equilateral, isosceles, and scalene when we're looking at the size of their sides. So that's everything you need to know about triangles for now. Next lesson we're going to talk about how we find unknown angles in triangles.